Okay, now let's see how to solve this. Now in the question, find the joint equation of pair of line passing to the point 2 minus c and parallel to the lines represented by so and so. Now if you look at the equation over here, x square plus xy minus y square is equal to 0, then it can be seen that this equation is not factorizable. So we are not able to find the factors. So what we do is, if I try to write the equation of this separate equation, I can write it in slope point form. That is y minus y1. Now y1 is given to me is equal to m. Let's say first line is m1 x minus x1, the first line, and y plus 3 is equal to m1 into x minus 2. Okay, I can take this on the one side, m1 into x minus 2 minus y plus 3 is equal to 0. Okay, this is what I can do. Now further, so we can call this equation number 1. This is the separate equation of the first line. Now what will the second equation? And the second equation is the second equation is y minus y1 is equal to, I'll take m2 x minus x1. So y plus 3 m2 into x minus 2. Even this will be m2 into x minus 2 minus y plus 3. Now these are separate equations that you get. Okay. So when I multiply these two separate equations, I will get the joint equation. So when I multiply these two separate equations over here, what will I get? Let's see. So when I multiply these two equations, I get m1. Now these are separate equations. The joint equation will be, let's take equation number 1, m1 into x minus 2 minus y plus 3 into m2 into x minus 2 minus y plus 3 is equal to 0. When you multiply these two, you will get m1 m2 x minus 2 square then what you will get is m1 y plus 3 into x minus 2, then m2 y plus 3 x minus 2. So if I take minus common, I'll get m1 plus m2 x minus 2 into y plus 3 and plus, when you multiply the final two, that is you get y plus 3 the whole square is equal to 0. Now this is what you get over here finally when you multiply these two. So I need m1 plus m2 and m1 into m2 now. I require m1 plus m2 and m1 into m2, these two values. So what I'll do is, initially I'll compare the given equation. I'll compare the given equation x square plus xy minus y square on comparing with the equation ax square plus 2hxy plus by square is equal to 0. I'll get a is equal to 1, I'll get 2h is equal to 1, and I'll get b is equal to minus 1. So when I get all this equation, all these values, I can find m1 plus m2 and m1 into m2. Now the value of m1 plus m2 is minus 2h by b. This is nothing but sum of the roots and product of the roots formula. So m1 into m2 and m1 into m2, m1 plus m2 and m1 into m2, you can get values. This is a by b, product of the roots. So minus 2h is minus 2h is 1, b is minus 1, answer is 1, a is 1 and b is minus 1, so you get minus 1. So you get m1 plus m2 and m1 m2 m2. Let's substitute these values in equation number 3. Okay, so if we substitute these values in equation number 3, we get the final joint equation. So when I put the values m1 into m2, you will get as minus 1. Okay, so I'll substitute over here itself, minus x minus 2 the whole square minus m1 plus m2 is 1 only, x minus 2 into y plus 3 plus y plus 3 the whole square is equal to 0. Now this is your final answer. You can multiply this by minus 1 and expand this to get the final equation actually. So if I multiply that by minus 1, I'll get x minus 2 the whole square plus x minus 2 into y plus 3 minus y plus 3 the whole square is equal to 0. Now if I expand this, I'll get x square minus 4x plus 4 plus, if I multiply this, I'll get xy plus 3x minus 2y minus 6 minus y square plus 6y plus 9 is equal to 0. X square plus, sorry, x square minus 4x plus 4 plus xy plus 3x minus 2y minus 6 minus y square minus 6y minus 9 is equal to 0. We can arrange this, and finally if we arrange this, we get the answer. Okay, so we can arrange this x square plus xy minus y square, then minus 4x plus 3x is minus x, then minus 6y minus 2y is minus 8y, and 4 minus 6 is minus 2 minus 2 minus 9 is minus 11 is equal to 0. This is the final answer of the given question, as you can see over here. Now, if you want to find a condition that a particular equation, like the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now this particular equation, if I want to check whether it represents a pair of lines or not, whether it represents a pair of lines, then we need to check two conditions. The first condition is whether it satisfies this AHG HBF GFC is equal to 0. If it satisfies this condition, first condition, and also it should satisfy the second condition. The second condition is h square minus ab should be greater than equal to 0. So if any equation that you want to check whether it represents a pair of lines, then we need to check these two conditions. The first condition is the determinant should be 0, and the second condition should be h square minus ab should be greater than equal to 0. So let's see the sum. Find the separate equations of the lines represented by x minus 2 whole square minus 3x minus 2 y plus 1 plus 2 into y plus 1 the whole square is equal to 0. Now to find a separate equation. Now the combined equation is seen over here. No? The given equation is a combined equation, but this looks a bit in a complicated form. But if you look at it carefully, you will find there are two terms. One is x minus 2 and other is y plus 1, which has been repeated. So if I substitute these two terms, so let x minus 2 is equal to capital X and y plus 1 is equal to capital Y. So that is x square minus 3xy plus 2y square is equal to 0. So this is x square minus 3xy plus 2y square is equal to 0. So this is your equation that you get, x square minus 3xy plus 2y square is equal to 0. Now I can factorize this now. That is x square minus 2 ones are 2, that is 2xy minus xy plus 2y square is equal to 0. Now if I take common, I'll get x minus 2y minus y x minus 2y is equal to 0. So x minus 2y in first bracket and x minus y in the second bracket is equal to 0. So we get x minus 2y is equal to 0, and I can say x minus y is equal to 0. So we get two answers over here. That is, these are two separate equations. X minus 2y and x minus y is equal to 0. So I can resubstitute now. What is capital X is x minus 2, and what is capital Y? That is y plus 1 is equal to 0. So this is x minus 2 minus y plus 1 is equal to 0. Finally, when you solve, you get x minus 2 minus 2y minus 2 is equal to 0. That is x minus 2y minus 4 is equal to 0. And if you solve the second one, x minus 2 minus y minus 1 is equal to 0. That is x minus y minus 3 is equal to 0. So the concept here is we substitute the similar terms, that is x minus 2. What we did is we have substituted the similar terms, that is x minus 2 as x. Okay. So these two are taken as x, and y plus 1 is taken as y. And then we factorize it, and then we separate it. And then when we separate, we again resubstitute. In place of x, we write x minus 2. In place of y, we write y plus 1. And then we expand and we get this. This is the next question, where we have to find k if the following equation represents a pair of lines. Now, if the following equation already represents a pair of lines, then this equation will satisfy the condition given by AHG HBF GFC is equal to 0. Since it represents a pair of lines, this condition will be satisfied. So now on comparing with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, we get a is equal to 3, 2h is equal to 10, b is equal to 3, 2g is equal to, okay, since there is no term over there, 2g is equal to 0, 2f is equal to 16, and c is equal to k. So if I compare this, I can clearly see a is 3, 2h is 10, and if I use h is equal to 5 over here, g is equal to 0, f is equal to 2, 8 is 16, and I put these values over here. So a is 3, h is 5, g is 0, h is 5, b is 3, F is 8, G is 0, F is 8, and C is K is equal to 0. Now, if you solve the determinant, you get the answer. 3 into 3K minus 8, it is a 64, minus 5 into 5K minus 0 plus 0 is equal to 0. So 3 3s are 9K, 3 4s are 12, 3 6s are 18, 192. Okay. Then minus 25K is equal to 0. So 9 minus 25 is minus 16K is equal to 192. So K is equal to minus 192 divided by 16. 16 ones are 16, ones are 16, 16, 2s are 32. So K is minus 12, and this is your answer. Now find P and Q of the equation px square minus 8xy plus 3y square plus 14x plus 2y plus q is equal to 0 represents a pair of perpendicular lines. Now over here it is already given that this equation over here represents a pair of lines as well as perpendicular lines. So I can split this into pair of lines also, and what he's saying pair of lines and also perpendicular lines. Okay, so there are two things over here, pair of lines plus perpendicular pair of lines. So perpendicular and pair of lines, I'll use two conditions over here. Okay, one condition is the determinant one, and other condition is a plus b is equal to 0. So I'll use two conditions over here. The determinant of pair of lines will be used over here. So what I'll do is I'll take this question and I'll compare it. So the determinant and a plus b. So determinant, that is the pair of lines, not a determinant. So let's see this. How do you solve this? So initially we'll compare the given equation. So on comparing the given equation with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So when I compare this, I get a is equal to p, 2h is equal to minus 8, b is equal to 3, 2g is equal to 14, 2f is equal to 2, and q is equal to c, or c is equal to q. I say c is equal to q. So I get these values. So I'll use both the conditions. The first condition states the determinant should be 0. Okay. The determinant should be 0 and also a plus b should be 0. So determinant, that is a, h, g, h, b, f, g, f, c. This determinant should be 0. Now, whenever I use this a, h, g, h, b, f, a is p, h is minus 4, because if I divide it, g is 2 sevens are 14. So I can find it over here. H is minus 4, G is 2 sevens are 14, F is 1 over here, F is 1. So F is H is minus 4, B is 3, F is 1, G is 7, F is 1, and C is Q. So these are the values that you substitute over here. And when you solve this, you'll get P into 3Q minus 1 plus 4 into minus 4Q minus 7 plus 7 into minus 4 minus 21 is equal to 0. Okay, so this is the condition that you get. P into 3Q minus 1 plus, okay, now there's not plus over here. I'll take minus 16Q, 4 sevens are 28, and this will be 25 into 7. Okay, that is 25 into 7, that is 7 into minus 25 is equal to 0. Okay, now you can leave this condition as it is over here, and you can actually go for the second condition. Now you use the second condition, that is, since the pair of lines, also represent the pair of lines also represent perpendicular lines, and therefore I can see a plus b will be equal to 0. Now if a plus b will be equal to 0, a is p and b is 3, that will be equal to 0, and so p will be equal to minus 3. Now I'll substitute this value of p is equal to minus 3 in the equation number 1. So when I substitute this value in equation number 1, I'll get minus 3 into 3q minus 1 minus 16q minus 28 minus 175 is equal to 0. So finally we get 3 3s are 9, minus 2 minus plus 3 minus 16q minus 28 minus 175 is equal to 0. Minus 9q minus 16q is minus 25q. 3 minus 20 is minus 25, minus 25, minus 25, 175 is, that comes out to be minus 200 is equal to 0. Now if I divide this, minus 25q is equal to 200, q is equal to 225, 4s are 100, so 25 8s are, that is q is equal to minus 8, and you get p is equal to minus 3. These are the two values that you want to find out. So over here, what we have done, to summarize, there are pair of lines, these are pair of lines which are perpendicular lines, so you can use this condition initially as well. Okay, but the main condition is determinant is equal to 0, and when I say determinant is equal to 0, I can say AHG, HBF, GFC is equal to 0. So this is the condition that I use, and this is the condition that I use. So these are two conditions which are very, very important. So you have to remember these two conditions. This is the first condition. This is the first one, and this is the second one. So these two conditions are very, very, very important. Let's come to question number 8. And the question number 8, find P and Q if the equation so and so represents a pair of parallel lines. Now on comparing the given equation with, on comparing the given equation with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. You get a is equal to 2, 2h is equal to 8, b is equal to p, 2g is equal to q, 2f is equal to 2, and c is equal to minus 15. So h is 4 and g is q upon 2, f is 2 ones are 2. Okay, so you got all the values now. Now after this, what we do over here is we use the conditions. Now since the lines are parallel, I can clearly see, since the lines are parallel, the condition that I'll use, h square minus ab should be equal to 0. And since h square minus ab is equal to 0, I can use h is 4 square minus ab means 2 into b is p, so that is 16 minus 2p is equal to 0. So 2p is equal to 16. So p is 2 8 are 16. P is 8. Now also, since I can clearly see p is equal to 8 is given to you. Also the lines represent pair of lines. Also we can say lines, that is the equation represents a pair of lines. The equation represents pair of lines. Equation represents pair of lines. Now, since it represents pair of lines, I can clearly see that the determinant should be again 0. So, if the determinant is 0, AHG, then HBF and HBF, GHC, GFC is 0. Now, I'll put the values over here. A is 2, H is 4, G is Q by 2, H is 4, B is P, F is 1, G is Q upon 2, F is 1, C is minus 15. This value should be 0. Now, if this value is 0, I can clearly see over here that is 2 into minus 15p minus 1, minus 15p minus 1, minus 4 into 15 fours are 60. That is minus 60 minus q by 2 plus q by 2 into 4 minus pq by 2. Okay. pq by 2 is equal to 0. Now we can substitute the value of p over there. Okay. So you can substitute this value now. 4 minus p, 2 into minus 15 into 8 is minus 120, minus 120, minus 1 is minus 121. Minus 4 into minus 60. Let's calculate this also. Minus 4 into minus 60 is plus 240. Minus into minus is plus 4q by 2. And this is again plus 4q by 2 minus, if I multiply this inside, q into, okay, p is 8. Q into q is q square by 2 2s are 4. So you can cancel this 2 1s are 2 2s are. So finally, let's see what remains is minus 242 plus 240 plus 2q plus 2q minus 2q square is equal to 0. So this is minus 2q square plus 4q minus 2 is equal to 0. So q square minus 2q plus 1 is equal to 0. So q minus 1 the whole square is equal to 0. So q is equal to 1. So I'm getting two answers over here. P is 8 and q is 1. So that we have used two conditions over here. The first is lines are parallel, that is s square minus ab is equal to 0. And the second condition is AG, HBF, GFC is equal to 0. So we have used two conditions over here. Now the next question has equation of pair of opposite sides of parallelogram. So if I draw a parallelogram over here, so let's have a parallelogram on this side. So if I have a parallelogram this way, let's say kind of rectangle if I draw. Oops, sorry. Now what he is saying is the pair of equation of pair of opposite sides of parallelogram. So pair of these are the opposite sides. These two are opposite sides and these two are opposite sides. So if I say A, B, C, D is a parallelogram and equations of opposite sides of parallelogram are, let's say, AB and CD. If I consider AB and CD and I consider AB and CD and the equation is x square minus 7x plus 6. Same way AD and BC. If I consider and let's say the equations are y square minus 14y plus 40 is equal to 0. Now, since it's a quadratic equation, when I solve it, I'll get two lines. Here also I'll get two lines. So when I get two lines and two lines, we have four lines and four lines will make a parallelogram. So let's see how to do this. So initially I'll factorize. So when I factorize x square minus 7x plus 6 is equal to 0, I get 6 ones are 6. That is x is equal to 6 and x is equal to 1. I get two equations, x equal to 6 and x equal to 1. If I factorize y square minus 14y plus 40 is equal to 0, I get two equations y, that is 4 tens are 40, y minus 4 and y minus 10 is equal to 0. So I get y is equal to 4 and y is equal to 10. Now these are the equations that you get. Now let's plot this on a graph. As you can see, this line over here is, this line is x is equal to 6. This line over here is x is equal to 1. This is y is equal to, you have the other line as y is equal to 4 and y is equal to 10. So y is equal to 4. This is y is equal to 4. And there will be one more line, which is y is equal to 10. We'll just have a look at the diagram once again. This line is x is equal to 4. This is x is equal to 1. This y is equal to 4. X is equal to 6 actually. This is x is equal to 6. And this is y is equal to 10. So you have all the four lines. So the four lines over here can be seen, x is equal to 6, x equal to 1, x, y equal to 4, y equal to 10. And the four lines will intersect at four different points. And the diagram, as you can see over here, since they are intersecting at four different points, you can see you are getting this point as over here as 1, 4. This point over here is 1, 4. This is 6, 4, 1, 10 and 6, 10. Now if I happen to join this, if I join them, that is if I join these points, I get two diagonals over here. So these two diagonals over here, they are asking us the joint equation of these two diagonals. So to find a joint equation of these two diagonals, if I name them A, B, C, D, then the joint equation of these two diagonals. For example, if I want equation of line that is diagonal AC, then I'll use 2-point form over here. I'll use these 2 points. The first 2 points that I'll use over here are 1, 4 and 6, 10. So 1, 4 and 6, 10. So x minus x1, that is 1, 4. This is x1, y1 and this is x2, y2. So x minus x1 upon x1 minus x2. I'm using the formula x minus x1 upon x1 minus x2 is equal to y minus y1 upon y1 minus y2. So this is x1 y1 and this is x2 y2. X minus x1 upon x1 minus x2 is equal to y minus y1 upon y1 minus y2. Now when we cross multiply, we will get the answer. So this is minus 6. Okay, if I multiply this, what will I get? Minus 6x plus 6 minus 5y plus 5 fours are 20. So minus 6x plus 5y, 20 minus 16 is 14. So this is the equation number 1 that you get. The second equation of diagonal, that is equation of line that is diagonal BD can be given by. Now let's see how to get the equation of diagonal BD. Again, we use the same formula, that is x minus x1. x1 is x1 over here is 6, 4, and x1 y1 is 6, 4, x2 y2 is 1, 10. So x minus x1 upon x1 minus x2 is equal to y minus y1 upon y1 minus y2. So when I calculate this, this is again minus 6x plus 6 6 are 36, 5y, 5 4s are 20. So minus 6x plus, okay, minus 6x minus 5y is equal to minus 20 minus 36 is minus 56. This is equation number 2. Now when we solve these two equations, that is minus 6x plus 5y is equal to 14, and minus 6x minus 5y minus 6x minus 5y is equal to minus 56. Now if I subtract these two, if I subtract, that is subtracting, what you'll get? This is plus. But this is plus, and again this is plus. So this will cancel out. You will get 5 plus 5, that is 10y is equal to 56 plus 14. You will get as, okay, you can get the intersection points over here. Okay. But wait, just a bit. Just a bit. What you want is, in the question is not the intersection point. You want is a joint equation. Okay, let's multiply these two. Let's not solve them. Let's multiply these two. Since we don't want the intersection point, we will just multiply these two equations. We don't want the intersection point, तो हम लोग इनको सिर्फ multiply करेंगे. So let's multiply these two equations. So multiply equation 1 and 2, we get the answer. The first equation is minus 6x plus 5y. So here we multiply these two equations over here, that is minus 6x plus 5y minus 14 equal to 0. And the second equation that you will multiply over here is minus 6x minus 5y minus 6x minus 5y minus 6x minus, just a bit, minus 6x minus 5y plus 56 is equal to 0. So we get this two equations and we multiply this. Finally, we get the answer, that is, if you calculate this, you will get 36x square minus 25y square minus 252x minus 252x plus 350y minus 784 is equal to 0. So this is the joint equation of pair of lines. Okay, so we did not find the intersection point over here since it's not asked over here. But if it is asked, you can find it by solving 1 and 2. We just want joint equations, so just multiply and get this answer. So this is what the question was that we had covered right now. Triangle OAB is formed by the lines x square minus 4xy plus y square equal to 0 and the line 2x plus 3y minus 1 equal to 0. Find the equation of the median of the triangle drawn from O. Now in the question over here, it is given that there are two lines. Joint equation of the lines is given to you. This line is 2x plus 3y minus 1 equal to 0. And the joint equation of these two lines, the blue ones, is given to you. So x square minus 4x plus y square is represented by this blue lines, and 2x plus 3y minus 1 equal to 0 is a straight line. So these are combined equation of two lines which are passing through the origin, and OAB is a triangle that is formed. You have to find the equation of median of the triangle drawn from O. So you have to find the equation of OC, that is median OC. Now will I find equation of median OC? I already know O. If I know C, if I know the coordinates of C, I'll get it. So how will I start? Now to start, I'll go for A. Let's say A is taken as x1, y1 and B is taken as x2, y2. Then coordinates of C will be, since C is the midpoint, C is the midpoint because OC is the median. OC is the median. So C is the midpoint of AB. And therefore I can say coordinates of C will be x1 plus x2 by 2 and y1 plus y2 by 2. So C will have coordinates x1 plus x2 by 2 and y1 plus y2 by 2. Now you have been given these two equations over here. We'll find one of the variables by using the first equation. Either we will get x or we will get y, and then we'll substitute the value over here. So I'll take the first equation. Okay, we can start with, let C be the midpoint of AB. Therefore, coordinates of C are x1 plus x2 by 2, y1 plus y2 by 2. Now what we want is from the first equation, that is 2x plus 3y minus 1 is equal to 0 is the equation of one of the line. So I can use either x or I can use either y. So what I'll do is I'll use x or y, any of them I can use. So this is called as elimination. In elimination procedure, you can either use or you can use y, x or y, whichever you are comfortable with. You will still get the same answer by using both of them. So elimination procedure works exactly identical irrespective of the variable that is used. So I'll substitute x. So 2x is equal to 1 minus 3y. So x is 1 minus 3y upon 2. I'll substitute this value, substituting value of x in the joint equation. The joint equation is x square minus 4xy plus y square equal to 0. So what is x? 1 minus 3y upon 2 the whole square minus 4 into 1 minus 3y upon 2 into y plus y square is equal to 0. Now when you calculate this, you will get 1 minus 3y the whole square divided by 4 minus 4 minus 12y into y by 2. So 1 minus 3y 2y into 4 is 2, 2 4s are 8. Now multiply this by 2. 8y minus 1 plus 2 12s are 24y square plus 4y square equal to 0. So this is what you get. Now when I solve this, I get 1 minus 6y plus 9y square minus 8y plus 24y square plus 4y square is equal to 0. Now 24 plus 4 plus 9 is 37y square minus 14y plus 1 is equal to 0. Now you get this as a quadratic equation. Okay. So the quadratic equation over here will have two roots. Okay. Since this is a quadratic equation, in y, this will have this equation will have two roots. Okay, it will have two roots in y. So let's say two roots y1 and y2. Now I use the concept of sum of the roots and product of the roots. So sum of the roots y1 plus y2, that is sum of the roots is minus b by a, that is minus b upon a, which is minus of minus 14 upon a is 37, which is 14 by 37. I will use this to find the coordinate, to find the y coordinate. Now check, this is the thing that we require over here. We require y1 plus y2 by 2. But I got y1 plus y2. Now I'll divide this both sides by 2. So if I divide both sides by 2, what I get over here is y1 plus y2 by 2. 2 sevens are. So this is nothing but the y coordinate of the y1 plus y2 is what? That is y, this, therefore y coordinate of C is 7 by 37. Okay, so you got y coordinate of C. Now this C also lies on this line. C also lies on 2x plus 3y minus 1. So I'll substitute the value of y coordinate over here and I'll get x coordinate. I'll substitute y coordinate over here to get the x coordinate. So substituting the value, therefore 2x plus 3y minus 1 equal to 0 becomes 2 into x plus 3 into, what is y? 7 by 37 minus 1 is equal to 0. So 2x plus 3 sevens are 21 minus 37 divided by 37 is equal to 0. 2x is equal to 21 minus 37 is 16. 2 8s are, therefore you got x coordinate also now. Coordinate of x also you got now. Therefore c will be 8 by 37 comma 7 by 37. Now you got the coordinates of c. Since you got the coordinates of c, we can use 2-point form now. Okay, so equation of OC, that is the median. Now O and C, O is 0 comma 0 and C is 8 by 37 comma 7 by 37. I'll use 2-point form over here. What is 2-point form? X minus x1 upon x1 minus x2 is equal to y minus y1 upon y1 minus y2. I'll use this 2-point form. This is your x1 y1 and this is your x2 y2. So equation of OC will be x minus x1. x1 is 0. x1 minus x2 is 8 by 37. Y minus y1 upon y1 minus y2, that is 7 by 37. So x upon minus 8 by 37 is equal to y upon minus 7 by 37. So when you cross multiply this, you will get this 37, 37 will cancel, minus minus will cancel, you will get 7x is equal to 8y. Therefore 7x minus 8y is equal to 0 is the answer. Okay, so this is your final answer. 7x minus 8y is equal to 0. This is the equation of the median. So I'll just summarize what we did. We have these two lines whose equation, combined equation, is given to you, and we have this line which is over here. So we eliminate this one of the variables and substitute over here so that we get either x or either y, value of either x or either y, and then we turn this into a quadratic equation in one variable. And then when we turn this into one variable, we get sum of the roots. Also product of roots we can get, but we require only sum of the roots. Since these are roots, I can get y1 plus y2 upon 2. So I divide here by 2. I'll get 7 by 37. And this is the y coordinate I got. Now C lies on this line also, this line. So I'll substitute this value over here. And I get the value of x. X is nothing but the x coordinate of C. And then I use equation of OC by 2-point form. This is the 2-point form. Now the question over here is, find the coordinates of point of intersection of line represented by x square minus y square minus 2x plus 1 is equal to 0. Now this is already a combined equation. So this is a joint equation and I want separate equations first. Okay. So when we are looking at this equation, this is joint equation. So I'll take x terms together. So x square minus 2x is what I have taken together. And x square minus 2x. And to make it a complete square, if I take this plus 1 also, this actually looks like the expansion of x minus 1 the whole square. Okay. And to support it, definitely the remaining term, that is minus y square, is equal to 0. Now this looks like a square minus b square is equal to 0. Now what is a square minus b square? This is your a and this is your b. So a minus b into a plus b is equal to 0. Then a minus b, a plus b. So I got the separate equations now. X minus 1 minus y is equal to 0 and x minus 1 plus y is equal to 0. So first equation that you get is x minus y is equal to 1 and x plus y is equal to 1. So there are two equations over here, and when you solve these two equations, solving x minus y is equal to 1 and x plus y is equal to 1, we can add them. X minus y is equal to 1 and x plus y is equal to 1, then add it, we'll get 2x is equal to 2, x is equal to 1. If I substitute it over here, so I'll get 1 plus y is equal to 1 and y is equal to 0. So this is a coordinate of point of intersection, because whenever you get two separate equations, and these are two separate equations, so you have to solve them simultaneously, that is you add them, no? So when you add these two equations, that is adding these two equations, we get this. Add or subtract, whichever is preferable, you do that and you get the point of intersection as 1, 0. So this is your answer.